Alright, so we're going to be talking more about predicting the products for this little video. I'm going to try to go a little bit more in depth and include some details that might help you. I know this is a hard topic, so make sure you watch the whole video to get all the information that you need. If you're still having questions after that, I actually made a little cheat sheet. It's about a page long that you can read through. And these are things that I keep in mind while I'm determining the products and trying to predict them. If you're still confused after reading the sheet and looking at the video, then please email me with your questions. I'm happy to help you. But let's get started. Let's look at this first equation. So write down the first equation and try to see if you can predict the products. Now you'll notice that we have one molecule over here. Li2O is all combined into one molecule. There's no plus sign. That would break it apart into two different things. This is just one molecule. So for this one, we know that it's going to have to split apart into two separate things because we can't just keep it as one thing. That wouldn't have undergone a chemical reaction. We have to split it apart into two separate things. So we're going to split it apart into Li and O2. Now you might be wondering why we have a 2 down here for the O, but nothing down here for the I, just a 1. And you'll remember that we talked about diatomic molecules before in class, and so this is a list of diatomic molecules. And this says that if you ever see any of these by themselves, like here, it's going to have a 2. They come in pairs. The Li is not on this list, so it doesn't have a number by it. It's just plain Li. The O is on the list, so it's going to have a little 2 by it. So that's just a note to keep in mind. So you have the Li2O. It's going to split apart into Li and O2. It's a decomposition reaction. Now if we finish balancing this, we see we have on this side 2 Li's, this side just 1, so we'll put a 2 there. Then we'll see that on this side we have 1 O, this side's 2 O's, so we need to put a 2 in front here. When we do that, we'll notice our Li now has changed to 2 times 2 to be 4, right? This goes to the O for 2 and to the Li, so it's 2 times 2 to 4. So we actually have to change this now to be 4 Li, and that's your balanced equation. All right, let's look at this next one. So write down this next equation. You can pause the video if you need to. You'll notice you have Fe with a plus 3. We have to tell you that it's a plus 3 here because you don't know the charge just looking at your periodic table for this one. So you have to get the charge from this problem. Now if it was a different problem with one that was in groups 1, 2, 3, 4, 5, 6, 7, if it's within one of those groups, then you wouldn't need the charge here. But since it isn't, we need the charge here to tell us. Then it's going to be combined with a Cl2. So this one is two separate products. They're going to combine to form one thing, all right? They have to. There's no other things for them to switch partners or anything like that. So this is how you know it's going to combine into just one thing if there's nothing for it to switch partners with or anything. So let's combine the Fe and the Cl2. So when we combine it, we're going to get Fe and we're going to get Cl. Now we need to figure out if we need any numbers down here. So to do that, off to the side, you need to see if the charges are balanced. So Fe has a charge of plus 3. That's from here in our problem. And then Cl, if you go to your periodic table, it's in group 7A. And we know from before this, this lesson, from a couple lessons ago, if it's in group 7A, it has a minus 1 charge. Now, you'll notice that these charges do not balance, so they need to switch the numbers. Swap, drop, and simplify, and we're going to put a 3 here for Cl3. Now we can continue balancing this equation. You'll notice on this side you have 1 Fe, so that's good. We have 2 Cls and 3 Cls, so we have to think about what common number we can multiply these things by to get the same. And we know that 2 and 3 both go into 6. So we're going to try to get 6 Cls on both sides. So if we put a 3 up front, that'll be 3 times 2 to get you 6. If we put a 2 up front here, that one will be 2 times 3 to get you 6 Cls. Now that we added a 2 in front here, this 2 goes for the Cl, but it also goes with the Fe. So we know if we have 2 Fe, then we need to also have a 2 in front of our Fe over here to get 2 Fe. Alright, the next two both look pretty similar. So we're going to have Br2 and Ki. And this is going to be a single replacement reaction. You know it's going to be that if you have something by itself that's going to go in and kick something else out. Now I think the problem that people get stuck on this is that they don't know which one of these they want to kick out. Whatever is most similar to this element is what is going to be kicked out. So for this Br, you think is K or is I have more similar properties to the Br? If you looked on your periodic table, you notice Br is a non-metal. It's in group 7A, and so is I. So Br is going to want to kick out I because they're the most similar. So when Br kicks out I, this is what you should get for your products. You should get KBr, and then you should get I, and then you should get a 2 down here. Remember, this 2 down here, it comes from it being a diatomic molecule. Now let's look at our KBr and see if we need any charges there. So we have K, it has a +1 charge. Br, it has a -1 charge. Those balance. You don't need any numbers down at the bottom. So now you can just go on to balance this reaction like you normally would. You'll see on this side we have 2 Brs, so we need to get 2 Brs on this side. You'll notice that on this side we have 2 Is, so we need to get 2 Is over here. And when we do that, you'll notice that our K is 2 now, and our K is 2. So that's a balanced equation. So now let's look at this next one down here. It's similar to the top one, but a little bit different. So you have NaCl and you have Mg. So the Mg is by itself, so it's going to go kick one of these things out. So you have to decide if it's the Na or if it's the Cl. So the Mg is most similar to the Na. They're both metals. The Cl is a nonmetal. These are also both positive ions. The Cl is a negative ion. So that's why the Mg is going to go kick out that Na. So for your products, you should get your Mg and Cl, and then you should get your Na by itself. Now we need to check to make sure we don't need any numbers. So we do Mg, and it has a +2 charge. You have Cl, it has a -1 charge. If you're confused about how to get these charges, please email me. It's from before. You can find it easy on your periodic table. I can explain it to you. Anyways, so we notice that these charges do not balance. They're different. So the 1 is going to drop over here. The 2 is going to drop over here. So you get MgCl2. Now we can try to balance this. You'll notice we have 1 Na, 1 Na. That's good. We have 1 Cl, 2 Cls. So we need to get 2 over on this side. So you add a 2. Then you have 1 Mg, 1 Mg. That's good. Now remember we put a 2 here, so we have 2 Cls to match that. But we also have the 2 NAs. So this one we need to change to get a 2 in front for 2 NAs. Alright, last one down at the bottom here. So for this one, I'm actually going to change something really fast just to make this a better problem. Sorry if you already wrote it down. But let's just change this really fast to help you see multiple things here. Let's put in an Fe here. So we're going to have FeCl2, and you're going to have an NaNO3. Now this one, there's multiple things going on here. First off, you'll notice that it's 2 different elements, and this one actually has 3 different elements. So when you have all these different elements going on, and you don't have something just by itself, you know you're going to do double replacement. So one thing is going to go swap places with another thing. And you always, again, do the things that are similar. So this Fe and this Na are both metals. They're going to switch places. You could also think of it, these 2 negative ions or nonmetals are going to switch places. But you just switch one of them. So I always like to just choose my metals and have them switch. So I'm going to make sure my Na is going to switch over here. My Fe is going to switch over here. So they're like switching partners. So when I do that, I get FeNO3 and I get NaCl. So now we need to figure out if we need any numbers down below here, as we call them subscripts. So if we look at this one, we have Na, it's a +1, Cl, it's a -1, those balance. So that's good. Our next one, we have Fe, and right now we don't know what its charge is. We can't just find that easy on the periodic table. So we have to use this NO3, and if we know the NO3 charge, you look at the polyatomic ion sheet, and it's actually -1. So to see if they balance, we need to figure out what this charge is. And in order to do that, you go back to this step, because this step will tell you what charge it has. So we have an Fe over here, not sure what the charge is. We have a Cl, and it has a -1 charge. So we have to work backwards and think, what charge does this have to have so that my FeCl will look like this up here? So if we know we're going to swap and drop numbers, this Fe must have a +2 charge to give Cl a 2 down there. Alright, so if we have Fe and it has a +2 and we have Cl and it has a -1, then when we swap and drop these, you get the Fe1 and the Cl2. Alright, so you kind of have to work backwards to figure out this, what charge the Fe has using this. So now that we know that Fe has a +2 charge, we can come over on this side and we can fill that in as a +2 charge. And we can finish doing our problem. So we see that a +2 and a -1 over here, +2, -1, those don't balance. So we need to switch them. So the 1 goes here, the 2 goes over here. So we get Fe, it has the 1. We have NO3, it needs to have a 2 for the whole thing. So when it has to have a 2 for the whole thing, we put it in parentheses and put the 2 out front. Alright, so now we can go on to finish balancing our equation. Let me kind of get rid of some of the work here for that. So if we want to balance this equation, we notice Fe and Fe are 1 and 1. That's good. Cl is a 2. Over here, Cl is a 1. So we need to add a 2 in front here for Cl to be a 2. You'll notice on this side, Na is a 1. Na here got that 2, so it's a 2 on this side. So we need to add a 2 in front here to get our Na to be a 2. Then we have 2 going for the NO3. Right, because this is just 1 NO3, but times by 2, so 2 NO3s, and on this side 2 NO3s, so it's balanced. Hopefully this was in depth enough to help you work on those problems. If you're still confused, please email me your specific questions. Also, like I said, I'm going to post this sheet that should walk you through the things I think about when I'm determining the products, when I'm deciding my subscripts, and reminds me about the diatomic molecules. Alright, please let me know if you have any questions. I know it's a long video, but hopefully this will help clear up things and make it a lot easier for you to predict the products now.